Hello friends, welcome to Shiksharthi. In this video, we shall be solving questions of exercise 7.1 on coordinate geometry. So let's start. Talking about question number 6, it says, name the type of the quadrilateral formed, if any, by the following points. And you have 3 subparts. So starting off with question number 6. You have to name the type of quadrilateral that is formed in all these 3 subparts, and then there may be a possibility that no quadrilateral is formed, and that is possible only when any 3 points out of the 4 points which are given to you may be collinear. I hope you understood. Okay, so talking about the first part, let's see the vertices as given. So it says 1 comma minus 2. So let's take the vertices as A 1 comma minus 2, B as 1 comma 0, C as minus 1 comma 2, and D as minus 3 comma 0. So using the distance formula, because in any case if you are trying to ascertain what kind of a parallelogram, whether it is a parallelogram or a rhombus or it is a rectangle or it is a square, one thing that is common to all of these is you need to find out the length of the sides. So as discussed in my earlier video also, if the length of all the 4 sides are equal, in that case the resulting figure, the quadrilateral that has been formed, the resulting figure will either be a square or a rhombus. But if a pair of sides are equal and parallel, if the pair of sides are equal and parallel, then we'll be able to say that the resulting figure that has been formed here is either a rectangle or a parallelogram. And then we go further to it, saying whether if the vertex angle is a 90 degrees, in that case, in the first case that we talked about, whether it is a rhombus or a square. So if the vertex angle are 90 degrees, in that case it becomes a square. And in the second case, if you are choosing between a rectangle and a parallelogram, if a vertex angle comes out to be 90 degrees, then it is surely a rectangle. It cannot be a parallelogram. Okay, using this logic, then we need to go ahead, because you need to reason out this before you go ahead with the question. Okay, so now in this, let me find out the distance using the distance formula. Distance here refers to the length of the sides. And the figure here is, the figure that we have considered here is, let us say any arbit figure you can take. So which is, let's say this is A, this is B, this is C, and this is D. Okay, so finding out with the help of distance formula, so how much is the distance between A and B? 1 minus 1 is 0 and 0 minus 2 whole square is 4, which is just like saying 2 units. B and C. So minus 1 minus 1. This comes out to be how much? How much is minus 1 and minus 1? Minus 2 whole square is 4. Now 4 plus 4 is 8, which comes out to be a 2 root 2. CD. So let me see whether the vertices that I have noted are correct or not. Minus 1 comma minus 2. Oh, this is minus 1 comma minus 2. So in that case, this also becomes a 2 root 2. The next is minus 1 comma 2. And finally it is minus 3 comma 0. Okay. So now in this case, when I am talking about C and D, so minus 3 plus 1 minus 2 whole square 4 and minus 2 whole square, which is 4. So which is again 2 root 2. And the same thing here, so which is 2 root 2. So in all likelihood, this is either a square or a rhombus. Now in order to prove that this is a square, if only one angle comes out to be, one vertex angle comes out to be 90 degrees, don't waste your time further, because in any case it is going to be a square, it will not be a rhombus. For that we just need to use the formula of the slope. So for 2 perpendicular lines, so now A and B are 2 lines which are perpendicular to each other. AB and CD, AB and BC is what we are considering. So the product of 2 lines which are perpendicular to each other, the product of their slopes will be equal to a minus 1. What is the slope for AB? 0 minus of minus 2 is 2, and 2 divided by 1 minus of minus 1, which is 2 again, which is 1. BC, 2 minus 0 is 2, and minus 1 minus 1 is minus 2, which is minus 1, which proves that these 2 lines are perpendicular. So which kind of a figure is this? It is a square. Talking about subpart 2. Now subpart 2, the coordinates are minus 3 comma 5, coordinate B 3 comma 1, coordinate C 0 comma 3, coordinate D minus 1 comma minus 4. Okay, now let me start off with the slope in this case, because there are only two things that you are going to use. Either you are going to, you'll be using slope formula along with distance formula to ascertain which kind of a figure is this, or you use one fully and the other partially. One here refers to one of these. Okay, so when I'm using the slope formula, if I'm able to prove that any 3 points are collinear, in that case it will never form a quadrilateral. Okay, so now let me find out the slope for AB. The slope for AB will be 1 minus of 5, which is minus 4, divided by 3 minus of minus 3, which is 6, which is minus 2 by 3. Slope of BC is just like saying 3 minus 1, which is 2, divided by 0 minus 3, which is minus 3. So can I say that the points ABC, so when I'm saying, so this is what we are saying. So are ABC collinear? Yes. So is there any quadrilateral which can be formed in the very first place? No quadrilateral can be formed. So now either you use the distance formula totally and then you use the slope formula partially to ascertain, or you start off with the slope first and then you use the distance formula. Okay, subpart 3 talks about, so again there are 4 coordinates. Let's say the first coordinate is 4 comma 5, the second coordinate is 7 comma 6, the third coordinate here is 4 comma 3, and the fourth coordinate here is 1 comma 2. So this gives me some hint. The hint here is I'll start off with the slope formula, and please identify that why am I starting off with the slope formula only. 6 minus 5 minus 1 divided by 7 minus 4, which is minus 1 by 3. BC, so the slope of BC. Okay, so the slope of BC is, can I say 3 minus 6 is minus 3 divided by 4 minus 7, which is minus 3, which is plus 1. Slope of CD, 2 minus 3, which is minus 1 divided by 1 minus 4, which is minus 3, so this becomes plus 1 by 3. And the slope of DA, the slope of DA is just like saying 2 minus 5, which is minus 3 divided by 1 minus 4, which is minus 3 again, so this becomes plus 1. Let me do it once again. 2 minus 5, or so if I'm finding out DA, so let's say 5 minus 2, which is 3 divided by 4 minus 1. Let me ascertain it for BC. So this is just like saying 3 minus 6 divided by, okay, let me find it out for CD. So CD is just like saying 2 minus 3, which is minus 1, 2 minus 3, which is minus 1, divided by 1 minus 4, which is minus 3. Let me just ascertain this value, because these are two slopes which are equal, so these are two lines which will be parallel to each other, but here comes the contradiction. So 6 minus 5 is 1 and 7 minus 4 is 3. Okay, fair enough. Now from here, can I say that AB is parallel to CD, and at the same time BC is parallel to DA? So what is the condition for parallelism? So if there are two lines which are parallel to each other, their slopes would be equal, right? So the resulting figure that will be formed here ideally should be a parallelogram. But in that case, you need to check with the help of distance formula that these lengths should also be equal to each other, which let us ascertain. So if I am saying 6 minus 5, so if I am finding out the length for AB, so the length for AB is 6 minus 5, which is 1, 1 square is 1, so and then 7 minus 4, so can I say this is root 10? Yes. The same should be the length for CD, which it is. Similarly, can I find out the length for BC? So 3 and 3, so 3 square and 3 square, root 18. Now this should be equal to dA, which is just like saying 2 minus 5 whole square, which is 3 square, and 1 minus 4 whole square, which is again the root 18. Henceforth, the figure that you are getting from here is a parallelogram. Let's move on to question number 2. I'm sorry, the next question here is question number 7. Okay, question number 7 talks about find the point on the x-axis which is equidistant from 2 minus 5. So, a point on the x-axis, we know that on x-axis, ordinate will be 0. On x-axis, ordinate would be 0. So, in that case, I can assume it to be x comma 0. So, from this point, which is equidistant from the points, so let's say this point is A and point B is given to you as 2 comma minus 5 and point C is given to you as minus 2 comma 9, and it is already given to you that AB is equal to AC. Okay, let me solve this. So can I say x minus 2 whole square plus 0 minus 5 whole square, which is 5 square, under root is equal to x minus or minus 2 whole square, which is x plus 2 whole square, plus 9 square. So when I square both the sides, I'll be able to write this as x, let's say x minus 2 whole square minus x plus 2 whole square is equal to 9 square minus 5 square. Now 9 square minus 5 square, you can simply use the formula a square minus b square, which is nothing but a minus b into a plus b. So how much is 9 minus 5? 14. 9 minus 5 is 4 and 9 plus 5 is 14. And the same formula you can use here. So once you subtract this from this and then you add, so x minus 2 plus x plus 2 will give me how much? 2x into, once you subtract this now, so x minus 2 minus x minus 2, which gives me minus 4. This is equal to how much? 4 into 14, which can be written as 56. So from here, when I solve, I'll get the value of x as minus 7. Once you get the value of x as minus 7, I hope it is correct. Can you ascertain the coordinates of A? Yes, it is minus 7 comma 0. Let's move on to question number 8. Now question number 8 talks about find the values of y for which the distance between the points this and this is 10 units. So there are 2 points P and Q. So the coordinate of P is 2 comma minus 3. Q is given to you as 10 comma y. And the distance between P and Q is given to you as 10 units. Applying the distance formula, you can say 10 minus of 2, which is 8 square, plus y minus or minus 3, which is y plus 3 whole square, is equal to 10 square, squaring both the sides. And then from here you can say y plus 3 whole square is equal to 10 square minus 8 square. Using a square minus b square, you will be able to say that 10 plus 8 is 18, and 10 minus 8 is 2, which is 36. Now using the concept of quadratic equation, can I say that if y square is equal to 36, I mean, let's assume that this is y, or let's say this is a whole square. If a square is equal to 36, then I can say a is minus 6 or plus 6. So using that concept, can I say y plus 3 is equal to minus 6 or plus 6? Going further, I can say that y is equal to minus 9 or plus 3. Can I say this? Okay, when I say this, then I need to substitute the values and find out whether this answer is correct. It has to be correct. So what are the various values of y that you are getting from here? Minus 9 comma 3. Let's move on to question number 9. So when I move on to question number 9, we see that the question as it is given here is, there is a point Q which is equidistant from P and R. So we have to find out the values of x. So a similar kind of a question we had done earlier, which is question number 7. It says Q is equidistant from P and R. Q is 0, 1. P is given to you as 5, minus 3. R is given to you as x, 6. and it is already given to you in the question that QP is equal to QR. So using the distance formula now, so can I say 5 minus 0, which is 5 whole square, which is 25, plus minus 3 minus 1, which is minus 4 whole square, 16, under root is equal to under root of 6 minus 1 minus 3, which is 9 whole square, which is 81, plus x minus 5 whole square. Have I done it correctly? Let me check it once again. So what are we saying? We are saying 5 minus 0, which is 5 square, is 25, minus 3 minus 1 is minus 4 whole square is 16. Okay, so root 41 is what we are getting from here. Okay, so when I square both the sides, we'll check that, but even before that, let me just check these values. So 6 minus 1 minus 3 is 9 whole square is 81, and this is 6 minus 5. So from here, can I say now that x minus 5 whole square is equal to, so when this goes on the other side, can I say this is equal to a minus 40? Please check in the meanwhile that the interim answer that I have got from here, is this correct or not? Because we are looking forward to the values of, find the values of x and also the distances between QR and PR. So first you need to find out the values of x. So there is a small mistake that I have done here, and the mistake here is we were supposed to find out this distance is QR, right? And this is not, we were not supposed to find it as PR, which is where the mistake lies. So now in this case, how much is 6 minus 1 whole square, which is 25, plus x minus 0 whole square, which is x square. So can I say from here that the value of x that comes out here finally, because 25 gets cancelled on both the sides and we are getting what, x square is equal to a 16, which means x is equal to minus 4 or plus 4. So these are the two values of x that you get. But then they were asking you to find out the distance also, and the distance that you are supposed to find out here is QR and PR. So the distance QR, whether you take minus 4 or plus 4, the distance of QR in any case will always be positive, and that comes out to be root of 41. And then you are supposed to find out the distance PR. That also you can find it out. Let's see how much does it work out to. So 6 minus or minus 3 is 9 whole square is 81. So let's say 81 plus how much do I need to add? X minus 5. So when I take this as minus 4, how much do I get? So minus 4 minus 5 makes it minus 9 whole square. So can I say this comes out to be a root 162? And the other value, for example, if I would have taken it as a 4. So when I take this as a 4, on one hand I am already getting a 9 square, which is 81, plus when I take it as a 4, I get 4 minus 5, which is minus 1 whole square 1. So this we get it as root 82. You can always solve this. Like this cannot be, but here I can say how much is this? Can I say this is a 9 square into 2? So ultimately this comes out to be 9 root 2, and this remains as root 82. Let's move on to the next question. And the next question is the final question, which is question number 10. So question number 10 says, find a relation between x and y such that the point x and y is equidistant from the point 3, 6 and minus 3, 4. Three, 6, let's say, is A, B, minus 3, 4, and C, let me take it as x, y. And it is already given that AC is equal to BC. So when I am using this, what will I get? Let us try and find that out. You are supposed to find out a relation such that x, y is equidistant from the points 3, 6 and minus 3, 4. You are supposed to find out a relation. How much is the distance AC? So now the distance AC, when I am calculating, How much am I getting? Let's see that. X minus 3 whole square plus y minus 6 whole square and the under root of this. What is the distance BC? The distance BC is nothing but x plus 3 whole square plus y minus 4 whole square, and then the under root of this. And then when you equate this, you are basically getting what? You are getting x plus 3 whole square plus y minus 4 whole square is equal to an x minus 3 whole square plus y minus 6 whole square, and then you solve for this. But if you start expanding and solving, it is a waste of time. So what my advice here is, bring the x component on one side, which is the abscissa component on one side, and the ordinate component on the other side of the equal to sign, which is the best way of solving this question. And then you apply the formula a square minus b square. Now when you are applying the formula a square minus b square, once you will be doing a minus b, and the next time you will be doing a plus b. So x plus 3 plus x minus 3 will give you 2x into once. Now when you subtract this, you will be getting x plus 3 minus x plus 3, which is 6. This is equal to this plus this, which is 2y. I hope I have done it correctly. And then now when you have, so once you add this, once you subtract this, so once you add this, you are getting 2y minus 10. And then when you are subtracting this, you are basically getting what? Y minus 6 minus y plus 4, which is minus 2. When you solve for this, you are getting basically 12x is equal to minus 4y plus 20. Then you bring it on this side, and then you divide it by a 4 at the same time. So you are basically saying 3x plus y plus 5 is equal to a 0. In the interim, please check whether the answer that we have got is correct or not. So the answer that we have got is correct with a small change here, because when you are bringing this entire on this side, this will be this. So can I say the answer is 3x plus y minus 5 is equal to a 0? Yes, it is. If you feel that here, when we are talking about the solution set, the solutions as you would have seen in all the questions that we have discussed here, if you feel that it is really complete and it takes your learning to the next level, wherein we talk about the basic concepts being used to solve the questions as and when required, and at the same time we are talking about the best and the basic ways both. Please do not forget to like, share and subscribe to our channel if you have already done so. Click on the bell icon and select all so that you get updates from us regularly. Thank you so much. Until next we meet, goodbye.